Good morning, students. In this video session, I am going to teach about linked list concept, okay, which is present in the fourth unit. Anyone aware about the linked list? In the first unit itself, I taught you some data structures like stack, queue, linked list. So, linked list also a data structure. What is data structure? What is data structure? What's the use of data structures? All the data structures like stack, queue, linked list, everything is used to organize or arrange the data in the memory. Okay, these data structures are used to organize or arrange the data in the memory. For that only we are using the data structures. Linked list is also one of the important data structure. Okay, now we can see the definition of linked list. What is linked list? Linked list is nothing but it's a collection, it's a linear collection or orderly collection or sequential collection. Linked list is a linear collection of data elements. Linked list is nothing but it's a linear collection of data elements. These other name of these data elements are called as nodes. These data elements are called as nodes. Each data element or each node consists of two parts. One is data and another one is a pointer which is denoting the next node. The good example for linked list is consider a train. All are aware about the train, right? So in that train, first engine is there, then many compartments are there and last compartment. Okay. Similarly, in the linked list also, first start, then many nodes are there. Compartments are nothing but nodes here. First engine is the start. Okay, starting position. The linked list chart should be considered as start or L symbol. Start or L symbol. Each compartment is considered as a node. And each compartment or each node consists of two things. One is data. Another one is the node, the pointer, which is represent the another node, next node. Okay. So each node consists of two parts. First one is data. Second one is the pointer. Pointer is nothing but holding the address of the next node in the list. All of you understood? Here the last node does not have the next node, right? There should be one end. So the last compartment or the last node should not have the pointer which denote the next node. So there we are represent the null symbol. Okay. For denoting the last node, we are represent the null or we are represent the slash symbol. Okay. Null is a preprocessor derivative and slash denotes the last. Both the things we can use. Similarly, for denoting the starting position, we can use start or L. Okay. So this is one node. This node have one data and one pointer. This pointer holds the next node. Okay. Address of the next node. Okay. So linked list is the concept of self-referential structure. See, the linked list, every nodes contain pointer to the another node which is of same data type. So it is called as self-referential structure. So your linked list is the good example for self-referential structure. Okay. Now there are various linked lists are there. Circular linked list, double linked list. In your syllabus, there is a concept of single linked list is there. So what is singly linked list means? In this linked list, each node contains only one link which denotes the next node. So as per my example, consider this is the train engine. That is the starting position. These all are compartments. This 1, 2, 3, 4 are compartments. Here it is nodes. Start is the starting position and this is the node. See, in the first node, the data element is 1. And here, there is one pointer, this arrow, which is denoting the next node. That means, it holds the address of the next node. The first node, pointer, holds the address of next node. Similarly, here one pointer, it holds the address of the third node. Again, here one pointer, it holds the address of fourth node. At the last, null. That denotes the end of the list. Okay. Now, if starting itself, in the start itself, if null is there means what's the meaning of this? your linked list is empty. In the start itself, null symbol is there, means the linked list is empty. No nodes are there. So now we are going to see about what's the need of linked list. For example, using dynamic memory allocation, you are going to create a memory. For example, using malloc or calloc, I want to create 2000 bytes of memory. Okay, 2000 bytes of memory. But as per calloc, if you are using calloc, means what will happen? Continuous memory allocation. Or if you are using malloc, means the space will be allocated. In the memory, there is no 2000 space continuously. So what will happen? Already some more applications are running in the RAM. So continuously you are not getting 2000 bytes. The system can't able to allocate 2000 bytes continuously. Okay. So what will happen? It can't able to allocate. So memory is insufficient. To overcome that only, they introduce the linked list concept. Listen carefully. Here how many bytes of memory are there? Totally 6 blocks, 6 bytes of memory are there. Okay. In the first byte, this red color denotes it is already full. This red color denotes already full. So now I want to allocate 3 datas. I want to store 3 datas. The first data is 4. Okay. The first data is 4. I want to arrange continuously. See, the second space is full. In this space, I put the data 4. The next place it was full. I can't able to allocate it. So if you are not using the linked list concept, means it's we can't able to store continuously 3 memory. So it leads a error. We can't able to allocate the memory. If you are using the linked list, means see here, the first position you are added the value 4. Correct. Then the next, what is this next? The pointer which is present in the node. Okay, which denotes the next address. Okay, in the first byte you are added the value 4. So in the next space you are not having any space, it was full. So this next, what's the next? Next is here pointer, which holds the address of the next memory. That's what I pointed here 3. So in the third position I am added the another value E. Again 2 blocks was full. Okay, in the 6th position I am adding the value N. So continuously I can't able to allocate the values here. So by using the linked list concept, the linked list concept means it's a collection of nodes. Each node contains 2 things. One is data, another one is pointer. Here next is a pointer which holds the address of the next node. So 3 is the address of the node, this E, data. Again 6 is the address of the another node which holds the data L. This is the way we can utilize the memory. We can organize the data in the memory very efficiently by using this linked list concept. So how to create the linked list means, for that we are going to use the concept structure, self-referential structure. Okay, so how you create the structure? Using the keyword struct. Okay, here the struct is a keyword and this node is the structure name. So each node have one data. So I am declaring one data here, and each node have one pointer which holding the same type. That is called as self-referential, right? Self-referential pointer. So struct node, it is a structure variable pointer. Okay. So this next will hold the address of next node. Okay. So see, if you create the node means, one data and one pointer. This pointer holds the address of the next node. Okay. Next one is for creating the list. For creating the list, first we have to use the structure. Then for creating the memory, we have to use the dynamic memory allocation. Already in the previous slide, I show the structure. The structure name is node, and there are 2 elements. One is int data, 2 bytes, and another one is one pointer, that is also 2 bytes. So the size of the structure is 4. So here I am going to create the structure variable. So struct node, 3 variables I am created here. One is new node, another one is pointer, another one is L. So L denotes the starting position. So I initialized as null. Null means we say it is a null pointer. If the pointer is initialized for 0 or null, we can say it is a null pointer. Okay. Now see here only I created the list. So I am using one user defined function void create. Inside that, see, I am using this pointer structure variable. This is a structure variable as a pointer. Okay. So I am using this pointer for dynamic memory allocation malloc. So as per this syntax, here one pointer will be required. Pointer only holds the address of the starting address of the memory. So new node equal to here typecasting. What's the need of typecast here? As it is a generic pointer, we have to specify how many bytes is used to create a single block. For example, here what's the size of struct? 4 bytes. So 4 bytes will be one block. Like that it will be created. That's what we are using this typecasting. Then malloc size of struct node. What's the size of struct node? 4 bytes. Why? Integer data. For integer 2 bytes. Then pointer default variable type is 2 bytes. So here the size of this struct is 4. Then I want to give the input for the memory, right? So 4 bytes, one node was created. One block of memory was created. It has 4 bytes. So I want to give one input and I want to assign the address of the next node for the pointer. Node means two things are there. One is pointer, another one is value. So here I am getting the value scanf. As it is a integer data type %d. Then as it is a structure element, how to access a structure element? Structure variable. If it is a normal variable means here we are using dot operator. Here the structure variable is a pointer. So you have to use indirection member. So here I am getting the input for data. Okay. So the next part of the node is pointer. So new node, this is next is the pointer. I am putting null, initialized as null. So only one node. Okay. Only one node I created. That's what I am putting null here. Okay. Then L equal to new node. So the first position, starting position, I assign this node. Okay. So this is the way you have to create the list. So the next one is searching a element in the list. So this is the algorithm to search the element in the list. For example, if you see this linked list, how many nodes are there? 4 nodes are there. 1, 2, 3, 4. This is the start and this is the ending node. Okay. So here consider your search element value is 3. Okay. So this algorithm is to search whether the 3 is present inside the linked list or not. Okay. So first step, set pointer equal to start. Here the start I am considered as a PTR. Okay. The other name of the start is PTR. That is I initializing the start to PTR. Now PTR not equal to null. Whether this PTR is null? No. Here it have 4 elements. It has 4 nodes. So it is not null. While not equal to PTR not equal to null. Condition true. So it will come to the next condition. If val, what's the val? Value is nothing but 3. Val equal to pointer dot data. For this pointer, what's the data? It's 1. So it's not matched. Condition false. So it will come to the else position. So pointer next, it will go here. Okay. Pointer dot next means this is the pointer. The next means it will come here. Okay. Again, while loop, here the next one is not null. The next one is 2. Okay. So next one is not null. Next one is 2. So again, val 2 equal to this. Sorry, val is 3, right? 3 equal to this 2. Again condition false. So it will come to the else part. Again next. So it will come here. So again it will check the while loop. Now val 3 equal to for here also pointer dot data is 3. So condition is true. So set position equal to pointer. The particular pointer value position will be stored into the position. Then I am printing the position. So this is the algorithm to search the particular element is present there or not. Once again I explain here. First, consider this is the starting position pointer. So I am checking while pointer equal to null. Here there are 4 nodes, so it is not null. So condition is true. Then if the value is 3, here pointer dot data, this is pointer, right? The first node. So pointer data, what's the pointer data here? Pointer data is 1. Okay. So 3 equal to 1, condition false. So it will come to the else part. Else is pointer, set pointer equal to pointerness. So you are assigning this pointer to this pointer. So now your pointer locating this. So again 2 equal to 3 equal to 2, condition false. So again it will go to the next node. Now 3 equal to 3. At that time the condition is true. The position will be the pointer value, pointer location will be stored into the position. Then just printing the position, then start. Okay. The next one is important thing, how to insert the element in the list. There are 4 ways we can able to insert the node in the list. 4 ways we can able to insert the nodes. First one, at the beginning we can able to add the node or insert the new node at the beginning. The second one is we can able to insert the node at the end. The third one is you have to insert the node after your desired position. For example, if your position is 2, means next to 2 your new node will be added. Similarly, the fourth one is before the node. If you are before the position, if the position is 4, means before 4 the node will be added. These are the 4 ways we can able to insert the insert the node in the list. So this is the algorithm to insert a new node at the beginning. So first I will tell the logic. You have to create one node, then you have to give the input for this node, then you have to add the node in the beginning. So void insert begin. Here the insert begin is the user defined function. This x is the data I am going to add. Then list L is the list. Okay, L is list here. So new node equal to, new node is a pointer. Here I am creating the memory. In the previous slide I explained, using my malloc you are creating the memory. Then I am checking whether it is created or not. If new node not equal to null, if it is null means memory not created, not equal to null means memory was created. So for that node I am giving the data, node dot data, then data is x. Okay, here for new node I create the memory, 4 bytes memory was allocated like this. Then I am assigning the value x. Okay, then new node dot next equal to. So what's the logic here? Insert the new node in the beginning. So beginning I want to add it, right? So at first L denotes the starting position. L's next node, that is L is the starting position, next node is there, right? That node will be linked at the back of the new node. Because I want to make it the new node at the first position. So the previously first position node want to be connected here. So I am connecting here. See, new node next equal to L's next. Starting, the previous starting's next will be added at the back of new node. Now L equal to new node. So L is starting. So you are assigning the new node as the first. Then L's next is kept at the back of the first node. So first you are creating the node here. Then this is the start. Then I created the node here. Okay. Then X will be assigned. Then I am giving the connectivity for the else nest. Then I am giving the connectivity for the start. So in the next slide it will be clearly explained. See, first new node X was created. Okay. So else nest means this A. So this else nest, this is the first connection. Else nest will be assigned to the new node's back. This is what this. Okay, new node nest equal to else nest. So this is new node, nest equal to else nest. Then this L is equal to new node. So this is the first node. Okay, all of you understood? So you are added the insert the new node X in the starting position. Okay. The second one is at the end of the list. Algorithm to insert a new node at the end of the linked list. So void insert n, another user defined function. Here also X is the data and list L is the list. Using a new node structure variable, I am created the memory for the new node. Again, I am checking new node not equal to null. If the condition is true means, if the when the condition will be true, if the memory is allocated means the condition is true. So if the condition is true means I am giving the data. The particular new node's data is X. Okay, why you are putting this arrow symbol? New node is the pointer. Okay, that's what you are using indirection operator. Okay, new node, this data is the structure element. For the data you are initialize the value X. So now the data is X. So here listen carefully. Here you are going to insert the node at the end. So how the end will be denoted? Null. You have to put the null. At last you have to put null. That's what you are going to add at the last, right? So new node nest equal to null. That means after the new node there should not be any nodes. It is the ending point. That's what I initialized here. New node nest equal to null. Okay. Then set ptr equal to L. Okay. Now I am using a ptr. The L is nothing but starting position. That will be assigned to the ptr. Then while ptr nest not equal to null. What's the meaning of this? So starting position nest should not be null. Okay, it should not be null. See the nest slide. This is the first position, start position, ptr. ptr nest is null, huh? No. Here 4 nodes are there. That's what. While ptr nest not equal to null means ptr nest. You are skipping nest like that. Okay. From here, if it is null, so first the pointer position will come here, then it will come here, then it will come, then it will come. Like that, you are reaching one by one. That's what. Till it reaches null. So still this place it will come. Not equal to null. So still this it will come. So outside the loop, once it reaches null, the condition will be once it reaches null, the condition will be false. So it will come out at that time ptr nest equal to new node. So once the while loop reaches here, it will come out. Then ptr nest. Okay. Still this the condition is true. Once it's come here, it will false. So the loop will be terminated. Then ptr nest means this place. This place you are adding X. Okay. The X was already initialized as the node was already, the nest was initialized as null. See here, ptr nest equal to new node. New node nest will be already initialized as null. So at the end point, you are adding the new node. Once again, I am repeating here. First, you are creating the memory. Okay. Then I am checking whether it is created or not. If it is not equal to null means I am assigning the structure element. New node is the structure variable. Then this is the access operator. Okay. This is data. For this you are initializing the value X. And the nest I am new node nest for this pointer I am initialize null. I am telling that after that no nodes was there. Null means ending point. Then the starting position L will be list starting position will be assigned for ptr. Then ptr nest not equal to null. Till it reaching the null point, you are positioning, you are forwarding the pointer position. Okay, nest from the first node to next node to next node. Like that you are positioning till it reaches the null value. Once it reaches the null value, the condition will be false, it will come out. So once it reaches this position, the loop will be false, come out. Next, ptr next equal to your new node. So it will be inserted at the end of the list. The third one is algorithm to insert the new node after the given node. So after your position, you are telling one position, after that position we have to insert a new node. Okay, so here I am taking a function void insert 1. Okay, so x is the data, list L denotes the list, and position P denotes the position. Okay, so new node equal to, again I am creating here new node equal to struct node, creating the memory. Then I am checking if it is not equal to null, new node data value is x, and new node nest equal to position of nest. What's the meaning of this? P means position, after your position. Okay, new node nest equal to P's nest. So position nest will be assigned to the new node nest. Okay, so position nest node is keeping nest to the nest node. Okay, nest to the new node. Then P next equal to new node. So after your position you are inserting the new node. So see this diagram. At first this is the starting position, this is the ptr, and this is the position. For example, this is the position. So see the pseudo code. First I am new node dot data equal to x, you are assigning the value x. For this new node you are assigning the value. Again new node nest equal to P's nest. So new node nest means this position you are adding the P's nest. Which one is P? This is P, right? This is the position. P's nest is this. So this link will be created first. This link will be created at the back of the new node. Then this link will be created. For that only this P's nest equal to new node. Now positions nest equal to new node. So once again I am explaining. First you are creating the new node, then new node data equal to x, you are assigning this value, then new nodes nest equal to P's nest. P means nothing but this B node, this node's nest. This link will be generated first, then position nest equal to new node, this link will be generated. So after this position the particular value will be added. The next one is insert the new node before the position. Okay, algorithm to insert the new node before the given position. So here I am using a function void insert. Again the list is L, x is the value, position P is the position. For the new node we create the memory. I am checking whether the memory got created. If new node not equal to null, this condition is true, means first I assign the value for the data. New node is the structure variable, access operator, data equal to x. Then I am assigning pointer equal to L. That means your list starting position will be a ptr. Okay, then I am checking condition while ptr nest not equal to position. The meaning is till it reach the position. Before the position, till it reach before the position, the while loop will be true. For example, see this is ptr. First it will come here. Here means it will reach the position not equal to p. So still this the while loop will be executed. ptr of nest not equal to p. At that time the condition will be false. Till that it will forwarding the position. Once the condition false, it will come out here new node nest equal to ptr nest. So first you are creating the link of ptr nest at the back of the new node nest. Then ptr nest equal to new node. See here First this is ptr, then the while loop will be executed. So ptr next, it will come here. Once the ptr reaches here, the while loop will be false. While loop will be false. So at that time new node will become. Okay, new node equal to ptr next. This link will be created first. Okay, so here the position is b. So before that you are creating the link. Okay, then this link will be created. First new node got created, then till it reaches the position. Before this position, the once it reaches the position, it will condition will be false. At that time new node equal to ptr's next. Okay, see here, new node next equal to ptr next. Then again ptr equal to this new node, so that you can able to insert the element in the list. Okay, so what are the things we discussed in this video session? First, what is linked list, what is singly linked list, then how to search a element in the list, how to insert a element in the